Good afternoon, everyone. Thank you for joining today's Technology Spotlight. We'll get started in a few moments to give everyone some time to join in the webinar. Let's get started here. All right, so good afternoon, everyone. Welcome to this month's Oracle Technology Spotlight. For today's topic, we will be discussing how your organization can enhance operational continuity and reduce downtime for critical systems with Oracle Maximum Availability Architecture. My name is J.R. Lazo, and I'm the Oracle Account Manager supporting the Department of Navy here at DLT. Before we get started, I want to go over a few housekeeping items. For Dawn customers on NMCI, we recommend using the Zoom link to view today's presentation. If dialing in, Zoom features will not be available. All lines will be muted during the presentation. If you have any questions, please enter them in the Zoom Q&A. We will address these questions throughout the presentation, but we'll also have a Q&A session towards the end of the presentation. If you're having any technical issues, please message either Felicia Cortez or the panelists via Zoom chat. This tech spotlight will be recorded, and a copy of the recording will be made available next week on the Dawn portal. If you would like a copy of these briefs sent directly to you, please enter your name and email in the chat section to the panelists, and we will send you a copy once available. So a quick review of today's agenda. To lead off, I will be providing a brief overview of the Dawn Oracle 3 Enterprise Software Agreement. Then Glenn Hawkins, Senior Director of Product Management with Oracle, will be discussing how Oracle Maximum Availability Architecture provides an essential framework for ensuring database resilience, combining advanced high availability and disaster recovery practices. And following that, we will open up the floor to Q&A. So a quick overview of the Oracle 3 Enterprise Agreement. In May 2023, NAVSEP awarded DLT an enterprise software agreement for Oracle licenses and services for a 5-year term. Authorized users of this agreement is the Department of Navy, including U.S. Marine Corps and approved contractor support. The managing activity for this agreement is the Enterprise IT Strategic Sourcing Program, or PNW 290. At the bottom of this slide, you will find a link to the DLT Marketplace, which is where this recording will be made available, but will also have information and resources regarding the Oracle Enterprise software. So the enterprise agreement can be broken down into two distinct parts, the unlimited license agreement and the agency catalog. In regards to the unlimited license agreement, authorized users have access to unlimited use of Oracle core technology licenses, including maintenance and support of these licenses. Core tech licenses include all versions of Oracle Database, WebLogic Suite, and Database Management Pack. The unlimited license agreement is centrally funded by the Department of Navy. In other words, what would typically cost around $60,000 for a single server license of Oracle Database is now a $0 ITPR as a result of this agreement. Navy users can obtain access to these licenses by submitting a Memorandum of Agreement, or MOA for short, through the DLT Marketplace. In regards to the agency catalog, Navy customers can procure most of Oracle remaining software licenses and cloud services that are not part of the unlimited license agreement at a pre-negotiated discount via the agent's catalog, which has static pricing through May 2028. To procure licenses and cloud services available on the agency catalog, authorized customers should reach out to DLT, to the Navy Oracle team at DLT for ordering procedures. As a reminder, per the Don CIO, this enterprise agreement is a mandated source of supply where all Department of Navy organizations and programs are required to use this agreement for their Oracle needs in order to achieve maximum cost savings through May 2028. So this slide highlights the key benefits of the Oracle 3 Enterprise Software Agreement. I won't read into each one, but there are a few I wanted to highlight. First point I want to highlight is that the ESLA improves the Navy's buying and negotiation power for maximum discount and cost avoidance. It also provides a centralized ordering platform via the DOT marketplace, which enables greater visibility, oversight, and control over software procurements. The ESLA also eliminates the requirement for justification and approval for catalog purchases at the ordering level. And the last point I want to highlight pertains to licensing virtual environments. This agreement allows Navy customers to reduce costs by using virtual processors as a license boundary for Oracle software license calculations. This slide provides a recap or a summary of what Oracle software is available on the unlimited license agreement and the agency catalog. To reiterate, in order to gain access to the licenses available on the unlimited license agreement, which are the licenses listed on the left-hand side of the slide, you would need to submit a MOA via the DLT marketplace. To procure licenses on the agency catalog, i.e. the licenses on the right-hand side of the slide, you would need to reach out to the Navy Oracle team at DLT for ordering procedures. This slide provides additional detail in regards to who are authorized users of this enterprise software agreement. But to summarize, all Department of the Navy organizations or principal elements of the Navy can leverage this agreement, except for when Don is serving as a Department of Defense executive agent, an entity which the Department of Navy is serving as a DoD combatant command support agent, or Navy Special Access Program. This slide has a link to the marketplace and a screenshot of the homepage. If you need any assistance with accessing this website or portal, please reach out to the Navy Oracle team at DLT. And with that said, that concludes the Don Oracle 3 Enterprise Software License Agreement overview. Next up, you'll be hearing from Glenn Hawkins, who will be discussing how your organization can enhance operational continuity and reduce downtime for critical systems with Oracle Maximum Availability Architecture. Glenn, take it away.
All right. Let me go ahead and share. All right, thank you, JR. So just to introduce myself real quickly and what my role is at Oracle. So I'm Senior Director of Product Management, so I'm part of the Oracle Database Engineering team. In particular, I run our Oracle Maximum Availability Architecture, which I'll be going through today, but DataGuard, Flashback, there's lots of different HA and DR technologies that my team owns, responsible for going ahead and essentially leading the product on the engineering, driving new features from an inbound and outbound perspective. So I'll focus on maximum availability architecture, but please feel free to go ahead and ask questions, type in a Q&A, any questions that you might have related to these technologies. I'll do my best to go ahead and answer them during the Q&A session. Otherwise, I'll just go ahead and jump into it. So the focus is on maximum availability architecture. We'll call it MAA for short. It's a solution. It's not a product at Oracle. It basically encompasses a bunch of different technologies and our best practices. So it applies to on-premises, Exadatabase, cloud-based, just about anywhere and everywhere you can go ahead and deploy an Oracle database. MAA can be applied now, and that's been expanded over the last year as well. So let me start with why MAA is so important. important. This kind of ties in with why Oracle created, because it is unique that we created these blueprints, and it's not just a set of blueprints. It's actually a team developer. So I'll kind of explain here in a moment. Um, but the impact of downtime, a lot of people, particularly if they're new to the industry, sometimes the last thing they think about after when they're developing an application is downtime, right? But the average cost of downtime can be quite expensive. I won't go through all these numbers. It's quite expensive. They make headlines. Obviously, they can impact a lot of users, and they come in different flavors, right? We have both planned maintenance, which is the most common type of downtime. Another thing that a lot of people don't think about. But that's your most common type of downtime. And then, of course, there's the unexpected outages that make headlines, can be difficult to recover from, and can result in serious data loss, impact to the overall business. So you can see how common this is. You can see how expensive it is. Always depends on the application, and how mission critical it is. So when I go through the presentation, I start talking about high availability disaster recovery. We segment those at Oracle. High availability is focused on mostly redundant components, ensuring that basically we can go up and running. If one component goes down, think if your compute goes down or one storage cell goes down, can I go ahead and have my environment be uninterrupted, right? And the same goes for type of patching events. On disaster recovery, we're talking about full site protection. Power outages that might impact an entire region, we're going to go ahead and fail over to another site usually. So we want to go ahead and have redundancy. We ideally want to do this with minimal data loss. Now we measure downtime and data loss in two different objectives. The recovery time objective is our measure of downtime from when the outage occurs, how quickly is our application back up and running again and serving its end users. And recovery point objective is your basically measurable data loss. Can I sustain some applications? If I just took a backup 24 hours ago, that might be okay, right? If I lost 24 hours of data. Others, I can't lose anything. Maybe the RPO is zero. So it's measuring the potential data loss if you cannot recover the primary system. If your production system is completely unrecoverable, how much data loss can I sustain? And usually we talk to people, when we talk about MAA, the first thing we do is ask people, what is your RTO and what is your RPO? What are your goals? Where are you today? And where would you like to be ideally from both a planned maintenance standpoint, unexpected outages, human error, anything that might occur. So that brings us into MAA and how we address basically high available and disaster recovery at Oracle. Um, as I mentioned, MAA isn't just a solution that we put out there. It's actually a team at Oracle. About 40 people. Most of those are focused on the database. Applies to our cloud, applies to our engineering system, applies to Exadata in addition to the database. Um, this team's been around. Some of them are veterans, been with the product for a long time. A lot of them go ahead and report their findings all the way up to Juan Luis and participate with Larry Ellison, who's still very involved at Oracle, believe it or not, on a routine basis, in especially on the Oracle database side and the decision making. So this team is extremely valuable. We work with a lot of different customers. Um, and MAA came out of basically support initially as we're going ahead and assisting these customers and creating recommendations from them. Best practices came out of that, and the team came out of it. And some key technologies came from that team that are heavily, heavily used at Oracle, DataGuard being one of them. It actually originated with that team as we had to move customers away from storage replication as they were getting too many corruptions. So I'll talk about that here in a moment. Essentially, four middle tiers is how we go ahead and define MAA, and they map into different RTO and RPO values. So once you determine what your RTO and RPO are, we can help map you into the appropriate tier. And there's a lot of variations within the tiers. So you hear bronze, silver, gold, and platinum, and they build on one another. So bronze is very, very important as silver, gold, and platinum build on top of it. So they're supersets of one another. And then on the right-hand side, here's our focus. And if haven't seen MA for a while, you may have noticed it expanded. Now we have high performance in there because essentially if an application's performance is down to the point that it's unusable, it's unavailable too at the end of the day. So we went ahead and we put that in there as well. That's a recent addition as we roll out 23i. And then we have the other categories: continuous availability, data protection, active replication, scale out, lifecycle. And you'll see a lot of the different features, RMAN, DataGuard, RAC, GoldenGate that you're familiar with. And a lot of them span more than one category in here, but they're all integrated together. So we have the technologies, and then we have the configuration and operational best practices, which the team goes through a lot of effort. If you search for DataGuard MAA best practices, you'll find all our documentation on RAC and GoldenGate and a lot on DataGuard, right? As far as going ahead um, and tuning it and configuring it and what we go ahead and recommend for each one of these tiers. And we've moved away from our traditional white papers to this documentation to make it much easier to navigate and keep up to date. Because it's a never-ending job for us. You know, things are constantly changing. We're constantly having new deployments, new features. So the team is always hard at work across all these different platforms. And those platforms basically span all the platforms that Oracle offers. You know, whether Oracle Database deployed in generic systems, Exadata, multi-cloud in one of our cloud services. And we have our zero downtime migration solution, which basically it works with DataGuard and GoldenGate under the covers to go ahead and provide the ability to move from generic systems to Exadata or up into the cloud um, without sustaining any downtime. So we have that as well. So as far as the way these different MAA tiers map into each other, our goal is definitely not to get everybody to platinum. I mean, a lot of these tiers have different cost structures tied to them. You need to have different data centers to have and multiple data centers to have more resiliency and be able to have site outages. And some of them at the platinum level even have a lot of moving components. So customers need to decide how critical the application is, right? Oracle, we can go ahead and provide zero downtime, zero data loss. We have the ability to go ahead and do that at the platinum level. So this is how we've gone ahead and mapped into the different tiers. But there's no rule of thumb on this, you know, as far as the way you want to do it. A lot of our customers, particularly those that run on Exadata, run their dev test and prod. They run it on Exadata as well, which automatically brings it to silver because RAC's in there. But this is kind of the idea of it. The majority of our mission critical customers are in gold, which means they basically have moved from HA to DR, right? They have a DR site available to them that they're replicating to. And the customers that really have zero RTO and RPO requirements, platinum is where it's at. And I'll go ahead and explain that as well. That's where GoldenGate comes into the picture. So one thing I want to mention is we really have MA anywhere and everywhere now that we're able to do it. And I realize that there's some limitations on the federal space as far as our rollout of these things. But you may have seen, and anybody came to Cloud World, we talked to a lot of customers, a lot of them in the public sector, about these new offerings that we have with Azure, Google, and now AWS, which we announced at Cloud World, where we're going ahead and actually running Exadata within these systems. Now, I'll talk a little bit about it, but once we get up to Silver MAA, RAC is always in the picture. And before you couldn't even run RAC in these third-party clouds. So now you can do it and on Exadata as well. So these offerings are extremely strategic to Oracle, and we're working very closely with all these vendors. You know, I think we're at a lot of the Microsoft conferences now this week, in fact, going ahead and kind of talking to their customers. But the MAA story now is completely everywhere and anywhere without limitations, without the ability to go ahead and exclude RAC from there, which provide a lot of limitations on it. That's really important. I want to say in 23 AI, there was 300 plus features that were rolled out in 23 AI, so a lot of features. And yes, 23 AI is not available on generic hardware yet. It's available on premises at Exadata, at ODA, and in our cloud. But it is basically the next main terminal release of the product. So it's where you should think about moving to. Hopefully you're on 19C right now. If you're not, it's a good time to get there. And then 23 AI is the next iteration on there. And we focused on a lot of these features. Of these 300 features, I grabbed a few that are focused specifically on availability and scalability here. Rolling patching being one of them. We expanded our ability to do rolling patches to complex changes. In particular, the OJVM for some of our customers at EBS, for example, had some challenges on there. We've gone ahead and we provided a lot more flexibility in the ability to do rolling patching there. We include fleet patching and provisioning now with RAC from a licensing standpoint. You get it. It's our gold image fleet patching solution that you can go ahead and do. Oracle Enterprise Manager has one as well called Fleet Maintenance, which you probably own as part of the Database Lifecycle Management Pack. For single instance databases, you also own fleet patching and provisioning, which is a similar solution. And then rack automatically goes ahead and includes it as well. And then we have a local mode now available that we've been calling FPP Lite. Um, so we have that. We have our globally distributed database, which is Oracle sharding, and now we have a new Raft replication that we have available for really quick setup on there that uses a consensus model. I'll explain that a little bit later. Fleet Pasture Provisioning also is available on XSCC, available in our cloud with Exadata Fleet Update. We have an in-firewall. Our database rolling, which I'll explain in a while, now has application continuity with it, which I'll also explain. And then we have more flexibility with DataGuard as well for hybrid DR configurations that our customers are going to use. Lots of different ways that you can go ahead and use that. When you start talking hybrid, there's a lot of options. And then we've done a lot of rack focused capabilities. You can see in here at least four of them that we go ahead and mention with order sequences, smart connection balance, our rack fast start. By the way, the grid infrastructure has also shrunk to, I believe, is it 1/3 of the size it was before? So for even the size of our solution, we keep that in mind. We've gone ahead and reduced the size. And clusterware also has more resiliency in it. We have True Cache, which is a caching mechanism built using the DataGuard replication, but it's an in-memory, right? So it's going to an in-memory database that you can go ahead and replicate to in front of your database to go ahead and increase your scalability and performance. And then we have all kinds of benefits on Exadata as well. That's just one sampling here, the RDMS-based Exadata rack scaling that we have available. And this is just a subset of everything. So what does this team go ahead and do and how is it unique? I mentioned that they're going ahead and I have a team of engineers that are going ahead and focused on this. So they're literally basically breaking things proactively to give you peace of mind is the goal. So they go ahead and you use a concept called chaos engineering to go ahead and create type of outages, literally pulling Exadata cells right out of the system without any warning while it's going ahead and running to make sure all our different failover and resiliency at the hardware level for Exadata, all the MAA best practices that we have for rack, DataGuard, GoldenGate, everything is working properly. They go ahead and create more best practices tied with that, update best practices, optimize best practices, simplify them when we add automation to them to handle all these different types of outages. And one thing about Oracle is we don't just focus on network, server, and storage outages, one you see at the top. There's lots of other kinds of outages, human error being one of them, right? Being able to go ahead and recover from that. Data corruption is a big one, right? That's tied with it. So your regular data corruption, you also have data corruption tied in with human or application error as well, right? That can happen. Data reorganization, application maintenance, right? Tied in with it. And of course, site failures, right? Power outages, hurricanes coming in. Those type of things all need to be go ahead and considered. And our customers really count on Oracle to go ahead and partner with them to ensure that they have that data protection in place. So let's jump into the different tiers and what we have here. So bronze is where it all starts, right? It's single instance with no clustering in the picture right now. So we just have single instance available to us. Usually our backup at this point is RMAN. We can see the RTO and RPO. So this is the first time you're looking at the outage matrix. So think about what your goals are from a recovery time objective and a recovery point objective, right? For data loss and eliminating downtime, right? Or reducing it. And a lot of times for an application, this changes over time, particularly if you have an outage. Your management, other decision makers may go, well, that was a little more severe than we expected it to do. It really impacted the business more than we expected. We need to reduce it. Or you start going, hey, we need to go ahead and we need to we're going to update our hardware. And you try to take some downtime for it. And all of a sudden, the downtime windows that you originally had, maybe that worked 3 years ago, people are not willing to accept that anymore. And you have to start evolving and thinking the way it may go ahead and start. So we have a lot of our customers that start at a lower tier, maybe bronze. And then as it becomes more critical, the requirements evolve. And you want your application to be very popular with the users. A lot of times we're dependent on this technology. They become more dependent on it, and then they can't afford for it to go down. And a lot of times you find yourself moving from one tier to the next. So a few technologies in here, which I'll talk about here in a moment, right? ASM, clusterware, RMAN, flashback, online maintenance, a lot of the stuff Oracle has and has had for a long time. Our competition sometimes announces stuff as like new features. Oracle really has had it for a long time, and a lot of these technologies are very, very unique. Um, and we keep on evolving, the multi-tenant being one of them. So 23 AI, technically 21C, you'll always have multi-tenant there. It'll just be one PDB. You wouldn't even notice it if you're not using it. But it gets you onto the container database infrastructure and all the fantastic things that you get along with that, which do reduce downtime at the end of the day, usually with different operations. Rapid provisioning, you can set up clones for your team members if you have some type of application error, you need to reproduce it in a different environment. Multi-tenant to the rescue. It can go ahead and quickly clone the technology and you can take advantage of it. By the way, when you get 3 PDBs with Database Enterprise Edition. So even without the multi-tenant, we have a multi-tenant option. You do not need it for up to three PDBs. You can take advantage of this. So the application remain unchanged. We have the portability. You can unplug the portable database, a PDB from one container, put it into another one that's upgraded. Use that as part of your upgrade process or part of your migration strategy. You can go ahead and manage many as one. So you can set up data guard on one container database that will protect all the portable databases inside of it. And you have a lot of control still to have silos for this. So you can have different isolation tied in with your portable databases as well as your PDBs. So we take advantage of it quite a bit. We even have our autonomous database serverless environment, which has hundreds and hundreds of PDBs running within the containers. So that's that shared kind of serverless shared version of autonomous database, unlike our dedicated version. RMAN, I probably don't need to explain to anybody who's familiar with the Oracle database. This is our backup solution at the end of the day. Tried and true. It can be has a lot of flexibility. You keep in mind that every time Oracle introduces a new feature, the RMAN team goes ahead and ensures that it works with the new data type. We have vector search, for example, database vectors for AI now running in the database in 23 AI. So we have to make sure everything's going in and backing up properly and it ties in with that, and we can recover very quickly from it. And then you have all the different backup options that you can go ahead and do to the cloud, to tape, whatever additional type of backup or archives that you want to take. A lot of people archive the data over time. So RMAN is kind of the core technology, and we build on that. I will just expand that in the interest of time. Is we have our ZDL array solution. It's our sometimes called the recovery appliance. It goes hand in hand with Exadata, and Exadata is always considered the best MAA platform because we have all the hardware redundancy in there as well, all the cells and everything like that. The hardware itself is meant to be redundant in addition to the software that runs on it. So ZDL array a lot of times goes hand in hand with it, but not necessarily only for this. It's used for incremental backups, right? We call it incremental forever. It uses data guard or active data guard specifically. You don't need to license it, but it's built into it to go ahead and work its magic and allows you to basically create after incrementals, you can take a virtual backup and recover from any point in time. And essentially, it's going ahead since you're getting the protection of data guard. Keep in mind that you can't fail over to it like you can a standby database. It's a recovery solution. But from a replication standpoint, it's using the same technology. And then it can be backed up anywhere you want. This is also our core technology if you want to understand how Oracle provides protection from ransomware, cyber attacks. ZDLRA is the product. And we have a ton of customers that are buying it specifically for that purpose, even more than the incremental backups. So it is a key technology on that because immutable, it provides all the protection. And then I like to mention Oracle Enterprise Manager at this part. We have monitoring built into it for Exadata, for everything that you see in here. EM is very useful for monitoring and configuring it and running compliance checks and all kinds of different things that we have available in that one as well. I know you own a lot of the different Oracle Enterprise Manager packs I saw in the list at the beginning. Now, two technologies I don't think we talk about enough that have been with Oracle for a long time, and we've been expanding it is our online operations or online redefinition that we have that allows you to go ahead and make changes to your tables while keeping your application online. Um, Now, this goes hand in hand with another product that has a similar name called edition-based redefinition, which allows you to go ahead and change applications without having any downtime. This one's actually using materialized views into the covers, and it's actually physically going ahead and changing the structures. So you can go ahead and delete columns, for example, or add new columns. You have the ability to go ahead and do this. It tries to minimize locking within there, but obviously some locking is available there, but it doesn't actually interrupt anything. Your queries, updates, everything will still go ahead and run through, tied with that. So that's one of our most popular features, and we virtually all our customers go ahead and take advantage of the RDBMS redefinition package. This is what we go ahead and call it. So that's your online operations. And then we have flashback technology, which is basically a rewind button for the Oracle database. But Oracle takes it a step further. We have a couple different types. So we have the ability to go ahead and do this not only at the database level, hit the rewind button, and you can see this excellent example of a human error which ran and accidentally gave everybody a nice promotion up to VP, which almost might be funny, except maybe it's connected to security, right? And all of a sudden these people have more access than they should. You really want to quickly fix this, but you may not want to have to recover from backup. It would be nice to go ahead and just rewind it, right? So Oracle allows you to do this not only at the database level, but at the query level, at the table level. You can go ahead and back out a particular transaction. We can also go back in time and query an older version of the database. We call it flashback, time travel, right? To go ahead and query to an older version. So we have a broader set of rewind capabilities than anyone else on the market to be able to go ahead and do this. And it's because we think of all the different types of down and out outages that you can go and experience. If someone makes a massive error, a human error, or maybe a new version of your application corrupts the data underneath and does something that it shouldn't, that essentially the application is up and running still, but it's not available at that point. So flashback can get you back up and running again very quickly. Um, Most of our customers use different variations of it. Sometimes you want to go ahead and size your flashback rewind database to make sure it can go ahead and handle whatever time interval you want to be able to rewind. And everybody uses this for reinstatement as well with Data Guard when they're do a role transition and recovering if they have to recover the primary after a failover. This is where flashback comes in. It has a bunch of other uses as well that we use it under the covers. I'll talk about here. So this brings us to high availability, and rack comes into the picture now. So real application clusters are clustering technology at the end of the day. It's something that we're quite proud of what we've gone ahead and done with this technology, especially as we went to 19C. We made so many improvements, enhanced the product so much, and optimized it so much from as far as management standpoint, from the capability standpoint, that virtually all our customers with mission critical applications are running on rack today. And historically, it's been the major reason that people couldn't even move up to third-party clouds because we don't allow rack normally to run in AWS or Azure, and those we don't certify it on there. However, now with the new ExaDB that you can run ExaDB in those clouds, Exadata running in those, I'll talk about a little bit later. We have that capability as well from that perspective. So you can see in red what's changed here in our outage matrix. In particular, from a planned maintenance standpoint, now we can do software and hardware updates with rolling patching. So rolling patching allows us to go ahead and do that. We can make hardware updates, software updates underneath. And now we've gone ahead and we can recover a node single-digit seconds. It just basically picks up. There's two technologies in here, though. Notice there's rack, and then we have another feature called application continuity. So what rack does is has all the clustering technology that we're talking about, multiple nodes on there. It's really incredibly optimized to go ahead and run an Exadata. You really get a lot of bang for your buck from a scalability standpoint, Exadata as well. We have the new features that I mentioned earlier, and I won't jump into them again, but we have all those capabilities from a kind of a planned maintenance standpoint, local rolling. We have two-phase or two-stage rolling patching now that we have available if the patch is complex enough that needs to be going ahead and run in stages. We have the ability to go ahead and do that too. It's not even mentioned on here. So rack is an area that we focused a lot on. From a patching standpoint, I mentioned we have fleet patching and provisioning that can patch. By the way, it can patch single instance databases, rack, and all the Exadata software as well, all using gold image patching. So all that way you have your compliance, your gold standards, and you're rolling out to these environments. It even has compliance detection in there, so it can go and detect if there's some kind of drift moving away from the gold images associated with it. So our recent enhancements on that is to focus on adding Exadata in here as well, tied in with this. And then Exadata Fleet Update brings us up to the cloud, as I talked about for ExaDB and XCC. And that brings us to the app continuity feature on top of that. So these are basically our great features that tie in with RAC. But transparent application continuity is part of RAC, in part of Active Data Guard. So it's kind of a feature and a feature. And what it does, its entire job is to go ahead and deal with your in-flight transactions. So from a standpoint of your committed transaction, RAC and Active Data Guard are already taking care of that for you. But what about the in-flight transactions? So you're basically, whether you're doing planned maintenance and you're getting ready to go ahead and roll through, maybe you're rolling through your different RAC nodes, or maybe you're going ahead and doing a full roll transition. You really don't want the end users to be impacted by that. Committed transactions, they're good to go. Those in-flight transactions would normally fail as the role transition occurred back to the application. The application could then decide whether it needs to reconnect, but now your developers have to think about that. They have to go ahead and design the application to reconnect, retry it, and all those type of things. TAC takes care of all that for you. It automatically rebuilds a session and replays the in-flight transactions. So goes ahead and replays them on another rack node, or in the case of Active Data Guard, it goes in and plays it up, replay on the standby database. I will say we have a ton of great MAA best practices with your application client connectivity that we recommend. So in addition to this feature, even if you're on single instance and you're not using rack and not using transparent application continuity, take a look at our MAA best practices for application client connectivity, where we talk about FAN, we talk about services, we talk about how to do session draining, and we talk about, particularly if you have a standby database, how to set up your JDBC URL, for example, not just Java, but whatever type of technology you're going to use, .NET as well, how to go ahead and reconnect properly and seamlessly as you go ahead and set up your environment. So we have all those recommendations in there. Even if you're using DNS as part of your role transitions, right? We provide guidance on that front that's worth taking a look at. And we got ahead and we enhanced those quite a bit about a year ago. Rolled out our different levels. We call them level 1, level 2, and transparent application continuity is level 3. It's where you really don't want those users to have any type of blackout at all. They just get a brownout. Essentially, they see a slight performance hit on their transactions before they're replayed with this technology. Very easy to go ahead and enable and doesn't require any changes to the application other than using the correct connection string. So now we talk about gold. This is really where data guard comes into the picture. It's really where disaster recovery. Up to this point, we did not have disaster recovery. We essentially have high availability. So disaster recovery is coming in, and you'll see a small diagram that we have in there has now have more moving parts in it as we start there, and we have a whole nother region that's available. A lot of times when we're talking about gold, you're talking about getting a certain amount of protection, a certain amount of blast radius that we call it, right, from the primary. Whether it's a power outage, snowstorm comes in, earthquake, or anything else that could impact that primary data center. We want to go ahead and we want to protect it so we can go ahead and roll over to another environment. Data Guard, inactive Data Guard, I'll talk about the difference here in a moment, are the protection solutions, right, for this. A couple things that you'll notice here. First of all, the outage matrix. Now you can see all the updates on disasters, and you can see the updates on major database upgrades, right? Those have now changed as well. Well, we still have all our rack. Keep in mind, we're building on top of Silver. So all the capabilities we have now rack in place, and now we're building disaster recovery on that. Notice one thing, that we have a local standby and a remote standby. Now, there's not one size fits all on gold. It really depends on how many data centers you have available to you. How much isolation. You don't need you don't need two data centers in each region, really, but you want some type of level of isolation. But it depends on your RTO and RPO value. And notice we have everything from 0 to seconds to minutes. Um, it depends on whether you want to go ahead and set up something like a local standby. And I'll talk about what that means here in a moment. But keep in mind that we have essentially synchronous replication, asynchronous replication that can happen over long distances um, without impacting the application itself. Um, so usually what we recommend is having a local standby that's set up with zero data loss. And then we have a remote standby, which can be further away. It's using what we call asynchronous replication, one of our different protection modes on DataGuard. And you may have ZDLRA, or you may have other types of backups. You're taking backups off those as well. And you take backups even off the standby with active DataGuard. Take advantage of that and take some load off your primary. And then notice a small little piece over there. We're using some of our cloud terminology like regions and availability domains. Availability domains 81 and 82 could be two separate data centers sitting next to each other. But if you don't have that available to you, maybe there are two racks sitting as far apart as they can. You're trying to just go ahead and get them like maybe separate network connections, separate power. So we go ahead and have some isolation, some fault isolation tied in with them. And given that they're really close together, we recommend fast start failover, which is part of DataGuard. If the primary can't be detected from an observer in from the standbys, it will go ahead and fail over to the roll, in the order that you've gone ahead and ready to go. First to the local standby. If the local standby is not available, then it'll fail over to the remote standby. All right. So, oops. So why did we create DataGuard in the first place? And I mentioned the MAA team has a historical part in that, right? That it went ahead and helped go ahead and create this. The reason is storage remote mirroring, storage replication is a great technology for applications, but not so great for databases, it turned out. So historically, if you went back before DataGuard existed, we were using storage replication to replicate the database. People still sometimes do this with VMware and things like that. It's very unsafe, it turns out. And it created a lot of problems, right? Because it replicates everything on disk. Meaning, if you introduce a corruption in the primary database, it replicates over to the secondary environment, which then, when you don't even know about that until you try to bring it up and realize, hey, I have the exact same problem that just took out my primary in my standby environment. So that's a bit of an issue. It's dangerous from a lot of standpoints, but the database is very sensitive to this. So we went in and created DataGuard. DataGuard does everything in memory. So it's only replicating the redo. It's not replicating everything on disk. And it very carefully validates all this along the way. It has immutability built into it, so you have ransomware protection. The integrity tied in with this, especially with the physical replication option, is just incredible what we go through to go ahead and protect the data along the way. And you have different, as I mentioned, different types of replication options, synchronous and asynchronous. In a nutshell, if I use synchronous replication, I guarantee that every transaction is going to be in my standby environment before I commit it to my primary. If I'm using async, I'm firing them over there, but there's no guarantee, right, that I have the same in there. Because if the network went down in the middle of it and my data couldn't reach it, and my primary went down, then I may sustain some data loss equal to what we call redo transport time. Whatever that network delay, and there's ways you can go ahead and calculate it. At least to some degree, you can estimate it. But essentially, it's leaving the window as your redo is going over the network. That's your async. That's why a lot of people will have a local standby, which gives them a lot of protection from a lot of different types of outages. And then they'll have a remote standby as well, set up in another data center, maybe hundreds or even 1,000 miles away. And they'll use async for that. Because if I use synchronous for that distant standby, well, my transactions are now waiting to commit, waiting for acknowledgement from the standby. And that could take a long time, right? Because of speed of light laws, for example. that may delay, basically create so many delays in my primary database that the application is just too impacted from a performance standpoint. It's just unrealistic. And there's no way to go about that, right? That is we have a couple of features which I'll talk about here in a moment. Um, but you're over long distances, you're really always going async just by default. All right, so data guard, what does it have in it? So, the core data guard started with replication, in-memory replication, and then we started to add all the validation. We created the automatic failover standpoint. We created a capability to go ahead and do rolling upgrades where you can go ahead and upgrade the standby. And we have a whole process that goes through turning basically our standby database from a physical standby into a transient logical standby, doing the upgrade there, and then rolling it back to the primary and rolling through it. It doesn't get zero downtime, but it has minimal downtime. Essentially, bouncing the database is what you're going ahead and working with from that standpoint. It's all very, very validated, and it's what we do in our cloud to a large extent. And then we have a ton of features, which you may or may not be aware of with Data Guard, inactive Data Guard, depending if some of the features fall into one or the other. Setting up with creating, we can create real-time cascading standby databases. We can clone databases for developers. And we have one of our most popular features is snapshot standbys. So essentially, you can go ahead and turn one of those standbys into a snapshot standby. It'll keep on replicating to that standby, but it will not apply the data anymore. Then you go ahead and can use that snapshot standby. You could run QA environments on it. You can do whatever you want to that thing. And then when you're done with it, basically you go ahead and return it back into a normal physical standby. It uses flashback to go ahead and flashback that database, and then it applies all that redo that hadn't been applied from the primary. But it already stored it, so that standby database is still ready to go ahead and recover from. You still can use it. The recovery time might be longer, of course, because redo apply needs to happen before it can be opened up. But a lot of our customers that have these type of features are using more than one standby that they have available to them. And you can have quite a few standbys. And then Active Data Guard is also able to go ahead and you can run read and occasional writes to those standby databases as well. And that's where the term active data guard actually came from, because the standbys are active. They're not just standing there, not just sitting there idle. They actually can be used for your read-only data. And we even have features in active data guard that are licensed, like global data services, that can be used for smart workload management to go ahead and send your read-only queries over to your active standby databases, taking workload off the primaries, going in and servicing reporting queries. Reporting applications sometimes only go against the active standbys, and if they have the occasional write, you can do that now as of 19C with that DML redirection feature that you see there at the bottom. So you can see Active Data Guard has become quite a larger solution at the end of the day. And it's also one of our most heavily invested solutions at Oracle, along with RAC. So with 23AI, one of the challenges we took, we'll say a very large credit card vendor, went ahead and we worked with them very, very closely to go ahead and achieve the RTO that they wanted to do over quite a long distance, I will say. So with some latency in there, they wanted to go ahead. So that's async, and that's our max performance, right? That's our mode, max performance mode, which is completely async. Max availability and max protection are some of our synchronous options. We were able to get a 3.5x performance on the role transition. It's actually one of the features that I'm most proud of. It's an enhancement, I guess, at the end of the day. So we don't have it listed as a new feature, but it's such an incredible leap for a technology that's been around for a long time. And I'm really proud of the team for being able to go ahead and accomplish this. And you get this improvement across all the different, however you're using it. This example is on Exadata, those graphs that you see, and we're using fast start failover to go ahead and tie in with that. So that basically is one of the main reasons that some customers are already going to 23AI or eager to get it for those trying to use it for generic hardware and take advantage of it. We also rolled out the ability by default data guards configured at the container database level for all the PDBs in it. But some of our customers wanted to be able to do it at the PDB level as well. and we did this, and we introduced it in 21C. We call it Data Guard per Pluggable Database, or DGPDB for short. And it allows you to go ahead and set up. It does mean having to configure each one of those PDBs separately, but it means those primaries, the container databases, they're essentially both primary because the PDBs within them could be a source or target, right? Could be a primary, or could be a standby at the PDB level. Um, you have to choose between configuring at the PDB level or at the CDB level. You can't do both. For most of our customers, they do it at the container database level because that's where you get all the different protection features. We had to roll out a lot of the active data guard features, like the real-time query, the ability to go ahead and query those target databases, use them for active standbys. So we introduced, that's a new feature in 23AI that enhances DGPDB. So now we have that main kind of active data guard feature. Over long distances, we have a couple different options. One of the cool features that we have in Act Data Guard is something called a FARSync instance. You don't have to license this as a little tiny small instance. Its entire job is to go ahead and collect basically the redo, which you can go ahead and store. It does not have any database files, no media. You're not failing over to a FARSync instance. It's pretty lightweight. But you could place it anywhere. So if you have, let's say, a smaller data center, we even used to have, we had a whole company that had created these like Phoenix black box machines that they were putting FARSync instances in that were basically very hardened and even had cellular network connectivity and all kinds of things. Whole building could follow them and they would still be up and running to collect the synchronize that data to ensure zero data loss. And then when it can connect up to the standby, it will go ahead and sync up with it. By default, of course, the standby is already up and running, so it just goes ahead and synchronizes to the FARSync instance and asyncs to as many standbys as you want. And we also have customers that use FARSync instances to feed data to a farm of standbys. That is an option as well, and we see a lot of people take advantage of it that way. It's a cool little feature also that you can offload your compression and your encryption to the FARSync instances. So lots of different ways that people go ahead and take advantage of it, even beyond its primary purpose of providing zero data loss over distance. But once again, it's kind of like the local standby. You need to figure out where you're putting the FARSync instance, right? This is a really important aspect to taking advantage of that. And you need to decide between that versus local standby. And a local standby I could set up as well. Of course, I would have to license it. And I'd want to put it on reasonably good hardware. Our FARSync instance is very lightweight. But there's a lot of different options they have in there. You could cascade off local standby on there, kind of similar to this. But the FARSync instance is a very efficient little component that we have available to customers. Rolling upgrades, I already explained this one. The one thing I'll say is that app continuity is now built into it, so it will go ahead as you're doing your upgrade. What it does is it has draining built into it, so application continuity will attempt to drain your transactions as it goes ahead from the primary to standby. Once it hits the drain timeout that you get to choose, at some point you go, okay, well, I need to go ahead and cut over. I can't just keep draining forever if it's taking too long because I have a certain window I want to do this in. No problem. App continuity will take care of replaying those remaining transactions for you over to the transient logical standby. So now that's now built into it. I will say that we're backporting this feature to 19C for the explicit purpose of upgrading from 19C to 23AI, but we're not there yet. It's not there. Something that we're going ahead and kind of working on from a 19C standpoint, but we plan to have that as well. So there we go. In the interest of time, I'm basically out of time, so I'm gonna click through the last few slides there. Platinum's at the top. You get to zero on everything, right? But it comes at a cost, right? GoldenGate's now in the picture, but GoldenGate needs to be configured in a high availability configuration with disaster recovery. The GoldenGate hub needs to be configured. GoldenGate is asynchronous by nature. So it gives you two primaries. So now I can upgrade one of my sites entirely on its own. I can stop replication. I can go ahead and upgrade one side. I always have data guard configured in each one of those environments, usually local standbys off each one of those. And of course, rack is still in the picture as well. So all the above. So we have these different options, GoldenGate being the big one. So GoldenGate bidirectional. I can have workload against both of those. And there's different conflict resolution that's built into GoldenGate that you can go ahead and take advantage of. Some automatic conflict resolution to go ahead and take care of most things. So you decide whether you want to have workload on one side, both sides. Maybe I want to be one load balancer away, click away from switching from one to the other. We've seen customers do all those different options. The one thing to keep in mind is GoldenGate is not a replacement for DataGuard, because DataGuard really has physical replication. This uses logical replication in it. And it's asynchronous. So it's not going to give you zero data loss, and it's not going to provide all the corruption protection um, that DataGuard does, nor the application continuity capability. So usually you want to have both of those. I will quickly mention EBR, but this could be a whole presentation by itself to do zero downtime application upgrades, not database, application. It allows you to have a current and an upgraded version of the application running against the same schema. So you have one schema, but you have different editions of that schema. So it adds another dimension to it. It involves basically putting editioning views in front of your tables, which are logical projections of those tables. So one physical table for all your editions, editioning views in the different versions that are basically servicing your current application and your upgrade application simultaneously. And there's triggers underneath the covers that handle basically the population of the different data. If you're interested in this feature, you can go ahead and take a look at the website. You can watch, I have a 45-minute presentation just on this that's recorded up there that I presented up on, if you just search on oracle.com for EBR. It's a really cool technology. It does require some thoughts as far as your application, as well as your development, how you roll out your application, how you take advantage of. We have some huge customers. One of the most known customers, that if you search around for references, you'll find Salesforce presented at some of our user groups. And they put their presentations up on the web. So you can go ahead and search for Salesforce and Oracle EBR, and you'll find some things out there, some guidance that they have on how they took advantage of it. But we make heavy use of this in Oracle too. EBS, OEM, Fusion apps. Anytime you hear zero downtime or near zero downtime upgrades for an application that are packaged app, it's probably using EBR under the covers. EBS being the biggest one. And then I already mentioned global distributed database, and I'm out of time on this. So I'm going to jump over the sharding capability that we have in there. Very cool technology, though. Allows you to have regional affinity, so you can keep different data in different regions. It's essentially you have gone ahead and you're splitting at the row level on a sharding key. And we decide which shard to put things in. Each shard is an Oracle database itself, with all the protection of RAC and DataGuard, GoldenGate, whatever you're using on it. And then we went ahead and we created the new Raft replication, which doesn't require DataGuard, GoldenGate, or even RAC. Basically uses that kind of that popular Raft distributed consensus protocol that has leaders and followers. Very good for locally going ahead and keeping things in sync. Over long distance, since it's all synchronous replication, it's probably not the best technology from that perspective. But if you have something that needs local protection and you have a sharded application, this is a great technology that's rolling out in 23AI. Really. All right. And in the cloud, autonomous database, you probably heard a lot about from us. We have autonomous data guard built into that. One click configures data guard for you. I'll leave it at that. We have the ability to go ahead and roll over the full stack, the application stack as well, and orchestrate it for you with our full stack DR service that's available in our cloud. It's available for XSCC now as well, and even Oracle DB at Azure. But it goes ahead and correlates the entire thing. Can go ahead and roll over your application, start up your volume, start up your application layer, and it integrates with DataGuard on all the different database solutions that we have at Oracle. So it's not a replacement for DataGuard. This integrates with DataGuard at the database level, and then basically expands it to the entire stack, your application stack. ZDLRA in the cloud. So I mentioned the recovery appliance. It's available in the cloud now as well. Zero data loss, autonomous recovery service, call it. We have hybrid options for you, which I won't go into detail. And I already stole my own thunder on the different what we have with Exadata database service running in Azure, Google, and AWS now, or AWS on the horizon. You heard basically if you watch the videos from Oracle Cloud World, you'll see that we're targeting that very soon to have it available there as well. And with that, I will stop as I've already run over all my Q&A time.
Yeah, I was about to say thank you, Glenn. It looks like we are running a little bit over what was allotted. So we just wanted to thank everyone for taking the time to jump on today's technology spotlight. If there are any questions related to this presentation, please feel free to reach out to the Navy Oracle team at DLT. But if not, a recording of this will be made available in by next week. But again, want to be considerate one time, so that thank you everyone for taking the time to meet.